Welcome to this lesson video. Today we'll be looking at gradient. Let us start. What is a gradient? A gradient is a slope of a straight line. The gradient between 2 points is determined by the ratio of vertical change and horizontal change. What is the equation of gradient? M stands for gradient. Our vertical change and horizontal change. This is the basic equation for gradient. And then when we expand, we have y2 minus y1, x2 minus x1. So basically we need 2 points on top of a line in order for us to calculate its gradient. Let us look at examples. Our first example. Suppose we have this line on top of a Cartesian plane. We have 2 points, which is point A and point B. We want to calculate the gradient. M is equals to y2 minus y1 all over x2 minus x1. Now we need to decide and label our points. Let's say point A is point number 1 and then point B is point 2. Now you can see that point 1, remember x coordinate is -2, y coordinate is 1, x coordinate of 2 is 1, y coordinate of point 2 is -3.5. We substitute. What is our y2? This is y2, x2, it's x1, y1. What is our y2? Our y2 is -3.5 minus, this minus is from the equation. I normally encourage that we put brackets. So this minus is from the equation. What is our y1? y1 is 1 all over. What is our x2? x2 is 1 minus, what is our x1? We have -2. I hope you can see this. Without wasting time, you can simply punch this on the calculator, and then we have -3 over 2. This is how we calculate the gradient. Let us look at example number 2. For this example, pause the video and work out this question. We are calculating the gradient. Play the video to verify your answer. Now remember, we need to label, so we have x2, y2, x1, y1. And then our equation is y2 minus y1 all over x2 minus x1. y2 is -3. Actually, I want to use a different color so that you can see the negative from the coordinates and the negative from the equation. Our x2 is 3 minus x1 is -1. So we have -3 minus 3. 3 positive and positive is +1. Our gradient is -6. divide by 4. Our answer is -3/2. I hope you got this one correct. Let us look at the last one. This is our next example. Pause the video, work out, play the video, and verify. We label x2, y2, x1, y1. Then the gradient is y2 minus y1 divided by x2 minus x1. y2 is 2.5 minus our y1 is -3.5 divided by our x2 is 2 minus our x1 is -1. From here we have 2.5 negative multiplied by negative is positive 3.5 divided by 2 negative and negative is positive. (2.5 plus 3.6), the answer is 6. 3.5 plus 2.5, the answer is 6. And then 2 plus 3, it's 3. Our answer is 2. This is our gradient. Our next question is a bit different. In this case, we are given the gradient. We are given the coordinates of the first point, and then we are also given the coordinates of the second point. But there's a problem with the second point. You can see that instead of a number, we are given a variable. It's unknown. So you are given the gradient of the 2 points or the line. We are given all the coordinates of the first point, and then we are given only the y coordinate of the second point. So we have x1, y1, x2, y2. And then we are given the gradient. So we are solving for x. y2 minus y1 all over x2 minus x1. Now where we see m, we substitute by our gradient. And then our y2 is 3.5 minus our y1 is 0.5 all over our x2 is simply x minus our x1 is -2. Now we need to solve for x. Let us start by removing the brackets. Negative and negative is positive 2. (3.5 minus 0.5), the answer is simply 3, and then we have x plus 2. Now we check. We need to get rid of the fraction. What is the number or terms causing the fraction? We can see in this case it's x plus 2. So we multiply both sides by the terms or numbers causing the fraction. You make sure that you multiply each and every term. Now this will simply result into 1. 1 multiplied by 3, we are going to have 3 this side. And then this side we have this bracket multiplied by this fraction. The answer will be divided by 2. And then from here we can see we have a new fraction again. We multiply by the number causing the fraction. This will result into 1. 1 multiplied by x plus 2, it's x plus 2, and then this side we have 6. From here we are going to transpose this to the other side, so we have x is equals to 6 minus 2. X is equals to 4. So the x coordinate is 4. Now from here, we can reduce the steps. We have 1 over 2, it's equals to 3x plus 2. We can see both of these terms are fractions, so we take the lowest common. In this case, we multiply each and every term by numbers causing the fractions. So you can see numbers causing the fractions, it's 2 and x plus 2. So you can see that I multiplied each and every term by the numbers causing the fractions. Now this and this will result into 1, and then we are left with 2 as our bracket. On the left hand side, this 2 and this 1 will result into 1. Then on the left hand side, you are left with x plus 2 multiplied by 1. Right hand we have 3, 2. So this multiplied by this, it's simply x plus 2, it's equals to 3 multiplied by 2, it's 6. And then when you transpose, we have x is equals to 6 minus 2, x is equals to 4. Our next part of the lesson, I want us to look at parallel lines. Now, what happens to parallel lines in terms of gradient? We know that when you talk about parallel lines, we have two lines which the distance between them remains the same and they will never meet. Then we say the two lines are parallel to each other. This is not parallel lines. These lines are not parallel. This is the only case when you say two lines are parallel to each other. This is line AB. And line CD. These two lines are parallel to each other. Now what you need to know is that whenever we have two lines which are parallel to each other, their gradients will be equal. So let's say the gradient of AB is 1 over 2. You must know that the gradient of CD will also be 1 over 2. Why? Because they are parallel to each other. These two arrows, they indicate that the two lines are parallel to each other. Our next example is based on two lines which are parallel to each other. We have line ABCD. We are given that the gradient of CD is negative 3 over 2, and we have the coordinates of AB. But we can see that the y coordinate of point B, actually point A, is missing, it's unknown. Now the question says calculate the value of y if AB is parallel to CD, and the gradient of CD is equals to negative 3/2. Now how do we calculate? Since line AB is parallel to CD, it means the gradient of AB is equals to the gradient of CD. We know the value of MCD. So we can simply expand y2 minus y1, x2 minus x1 is equals to MCD. Remember, this side is for point A, this one is for point B. Actually, it's point AB, I'm sorry, point AB, and then this side we have CD. y2 of point A, it's -1 minus, we simply have y, we have 0 minus, we have -3. It's equals to our gradient for CD, it's -3/2. From here we can start solving. We have -1 minus y, 0 minus negative multiplied by negative is +3, so we have 0 plus 3, it's equals to -3/2. We have -1 minus y over 3 is equals to 3/2, -3/2. -1 minus y all over 3, I can rewrite this as -1.5. So I only have one fraction in this case, that is 3, so we multiply both sides by 3. This will result into 1, and then I'm left with -1 minus y, it's equals to -1.5 multiplied by 3, it's -4.5. And then what I will do, I will transpose, actually I will double transpose, take this to the other side and then bring this one this side. So taking this one to the other side, I'm left with -1 plus 4.5 is equals to +y. Y is equals to -1 plus 4.5, the answer will be 3.5. This is the y coordinate. This is how we apply the knowledge of parallel lines. Our next part of the lesson is perpendicular lines. Now, what do we mean, or when do we say two lines are perpendicular to each other? Now let's say we have the first line, which is AB. Then we have the second line, which is CD. You can see that we have a point of intersection. This is the point whereby two lines they intersect each other. If the point where two lines intersect each other forms 90 degrees, then you say the two lines are perpendicular to each other. something like this. Two lines are perpendicular to each other. Perpendicular to each other. So what happens when two lines are perpendicular to each other in terms of gradient? The product of the two gradients will always be -1. This is the equation. It's the basic equation. We can rewrite it in terms of bracket -1. When you further expand this, it will be y2 minus y1 all over x2 minus x1, y2 minus y1, x2 minus x1, -1. Remember, this is AB, this is CD. Our example is this one. We are given two lines, line A, B, C, D. The gradient of CD is 1. The coordinates of A is x, maps 3.5. For B it's 0, maps -1.5. Calculate the value of x. The two lines are perpendicular to each other. Now remember the gradient of AB multiplied by the gradient of CD. Our answer will be -1 provided they are perpendicular to each other. Now we have this one, no need to expand, so we can expand this. So where we see MCD, we substitute by our gradient, -1. What is our y2? Our y2 is -1.5 minus our y1 is 3.5 actually. Our x2 is 0 minus our x1 is simply x, all multiplied by 1, it's equals to -1. From here we can see that basically this bracket multiplied by 1 is simply the bracket, so we can remove the square brackets and then we are left with -1.5 minus 3.5. 0 minus x is -x. It's equals to -1. -1.5 minus 3.5, the answer is -5 all over -x is equals to -1. This will simply cancel each other, so we have 5 minus x is equals to -1. In this case, the term which causes the fraction is x, so we multiply both sides by x. This will result into 1. 1 multiplied by 5 is 5, it's equals to Negative 1 multiplied by x, it's negative x. So basically we have negative x is equals to 5. Now how do you remove? Remember we are solving for a positive variable. X shouldn't be negative. So we divide both sides by negative 1. Then this will result into 1 multiplied by x, it's x is equals to negative 5. That's it for this lesson video. This is Babula SJ. Thank you very much.